In this example, we'd like to once again calculate the net torque acting on our object, the board. Now, let's suppose we have three forces as shown that are acting on our board that is rotating about an axis of rotation found at the center of mass right in the middle of our board. Now, we want to calculate the net torque knowing force 1 has a magnitude of 80 newtons, force 2 has a magnitude of 30 newtons, and force 3 has a magnitude of 70 newtons. Now let's make the assumption that the entire length of the board is 5 meters long. So that means from the axis of rotation to one edge is half of 5 meters, so 2.5 meters. So, in the beginning, our first step is to find the formula for the net torque. Well, the net torque is simply the sum of all the torques created by all the forces. So we have three forces, and that means we have three torques. So torque 1 is the torque created by force 1, torque 2 is the torque created by force 2, and torque 3 is the torque created by force number 3. Now, let's begin with torque 1. What exactly is torque 1? Well, torque 1 is created by force 1, and to find the value for torque 1, we simply find the force that acts at an angle perpendicular to our lever arm. The lever arm we're going to choose to be R1, the distance from the center to one of the edges. Now, that means we have to find the y component of this force. So that means we simply take the sine of the angle 30 and multiply it by the magnitude of F1. And then we take that force and multiply it by the lever arm, and that's torque 1. What about torque 2? Well, notice torque 2 has a lever arm of 0. And that's because the force acts at the axis of rotation. So because the lever arm is 0, the torque is also 0. So torque 2 becomes 0. What about torque number 3? Well, torque 3 once again is the force that is perpendicular to the lever arm, and the lever arm we choose to be R3, beginning at the axis of rotation and ending on the edge, at the edge. So that means we have to find once again the y component force. So we take the sine of the angle 45 multiplied by our force or magnitude of force 3 and multiply that by the lever arm, R3. Now we know what F1 is, it's 80 newtons. We know what sine 30 is, it's 0.5. We know what R1 is, it's half of 5, so 2.5 meters. We know what F3 is, that's simply 70. We know what sine of the angle 45 is, that's radical 2 divided by 2. And we know what R3 is, it's simply 2.5. So notice both of these forces create a torque that rotates in the same exact positive counterclockwise direction. So that means we add up these two values. So 80 times 0.5 is 40 times 2.5 is 100. So we multiply 70 by 2.5, multiply that by radical 2 and divide by 2. We add these two values and we get approximately 224 newtons times meters. And our direction is counterclockwise in the positive direction. So our board will rotate in the counterclockwise direction.